Good afternoon. This session is for MMPC 9. I will wait for another
Good,
2 3
good
minutes
afternoon. Okay,
and then we will start.
okay,
Today
sir.
we will be talking about value engineering and quality assurance. And to the later part. Tomorrow we will be finishing it up if no extra sessions are required by you people. Okay, now welcome back to the session for MMPC 9. Today we will be talking about value engineering and quality assurance. This part is much more related to engineering concept and quality. First of all, we will start with what is value engineering and what is value analysis. Or are they? Very good evening, Vasant. How are you?
Doing great, sir. Thank you very much.
Okay, I really found you in the last session.
Yes, I got busy actually. I had something to do. Sorry, I missed that.
Oh,
Sorry.
no issues, no issues. Today, right now, I'm talking about MMPC 9, not MMPC 8.
Yeah, sure, sir. Thank you.
Okay, I will continue. Value engineering or value analysis is an important and powerful approach for improvement in the performance of the product, systems, or procedures and reduction in costs without altering or jeopardizing their function. The term value engineering and value analysis are used almost interchangeably. Other terms used to convey the same concept are value assurance and value management. I will be sharing the slides. Wait. Nothing to worry about that. LD Miles defined value analysis as an organized, creative approach which has for its purpose the efficient identification of unnecessary cost. That is, the cost which provides neither quality, nor use, nor life, nor appearance, nor customer features. Value engineering should not be treated as a mere cost reducing technique or cheapening of the product. It is more comprehensive, and the improvement in value is attained without any sacrifice in quality, reliability, maintainability, availability, and aesthetics. It was traditionally applied in the area of hardware projects, such as product design, though these concepts are equally applicable in software projects, in the system, and the procedures. Now, what is the difference between value engineering and conventional cost reduction? As far as value engineering is concerned, it is a function oriented. It applies innovative approach and ideas. It exercises maximum creativity. And there could be a divergent convergent idea. There is a cost visibility on the following functional basics, that is basic function, secondary function, unnecessary function, and the essential function. If we talk in terms of the conventional cost reduction, it is item oriented. It follows past practices. It is analytical in approach, and there is only convergent ideas. There is cost visibility on the following parameters, that is part component wise, process wise, material, labor, overhead, transport. These are the areas where it is work. There is a tendency towards compromising quality and reliability. It's very well understood when you are reducing the cost of anything. I'm not saying any product, anything. That means you are compromising with its quality and reliability. And the approach is arbitrary and ad hoc. But as we talk in terms of value engineering, that approach does not compromise with performance, quality, and reliability. And there is a systematic and sequential approach. Now comes your function and value. Function is a basic purpose of an item or an expenditure. It may also be a characteristic that makes item work or makes it sell. Miles define function as the basic purpose of each expenditure, whether it be on hardware, the work of a group of man, a procedure, or whatever it is accomplished to a function. Types of function. Value engineering discipline deals with the function of item, products, systems, and procedures. It is a functional approach, a customer oriented approach. Identification of the functions, therefore, constitutes an important aspect of value engineering. The term function is used to mean the purpose or to use of a product. Functions can be of two types. Basic function, the primary purpose of a product. And the secondary function is the other purposes not directly serving the primary purpose but supporting it. Many a time, poor value may result in because the function have not been precisely understood and redundant or unnecessary function have been imposed. Value. The term value is used in many different ways and is frequently confused with the monetary price or cost of an item. However, value is not synonymous with cost. Value may be perceived as the ratio of the sum of positive and negative aspects of an object. Thus, value can be considered as a composite of quality and cost. It is more in terms of worth or utility. A ratio of quality to cost can be treated as value of the product. If its cost can be reduced, the same quality or quantity can be improved with the same cost. Then the value improvement can be said to occur. The term value can be divided into four parts, that is, use value. The properties and qualities which accomplish a useful purpose or service. Esteem value. The properties, features of attractiveness which causes us to want or own it. Cost value. The sum of labor, material, and various other costs required to produce it. Exchange value. The properties or qualities which enable us to exchange it after some time else we want. These are the things which we normally prefer to understand or prefer to do. Value engineering job plan. The major advantage of the approach is that it is a systematic and organized approach that examines all aspects of a problem, employing a questioning attitude. This formal procedural model of value engineering process is called value engineering job plan. In the beginning, Miles proposed value engineering job plan. It was just a modified form of the steps involved in work study. Subsequently, it has been modified and a number of approaches have emerged which are essentially similar. These job plans have various steps and phases with their associated value engineering techniques at each phase. In one of the job plans, the seven steps involved are preparation, problem selection, information, evaluation, creation, selection and presentation, and implementation and follow up. The salient features of three different approaches to conduct a value engineering program are job plan due to much, tertiary method, and the FAST, that is the function analysis system technique. The job plan due to much is very well recognized approach. The seven phases of job plan are journal phase, information phase, function phase, creation, evaluation phase, investigation phase, and recommendation phase. The journal phase plays vital role throughout the and provides a good base for other phases to succeed. Now question is what is journal phase? Throughout the application of the entire job plan, the techniques of this phase must be diligently applied to create the right environment for value engineering job plan to be effective. There are five techniques associated with this phase. First one is use good human relations, inspire teamwork, work on specifics, overcome roadblocks, and apply good business judgment. Second phase is information phase. The objective of this phase is to gain an understanding of the project being studied and to obtain all essential facts relating to the project as also to estimate the potential value environment. These phases comprises of three techniques. Secure facts, that is technical specification, engineering drawings, features preferred by customers, scrap rates. Secondly, determine cost. And thirdly, fixed cost on specification and requirements. Once the technique of the information phase has been used to secure pertinent data, the function phase of the job plan can be used. Third one is function phase. The objective of this phase are to define the functions that a product actually performs and is required to perform, as well as to relate these functions to the cost and worth of providing them. The two techniques of this phase are a major part of the functional approach. When combined with other techniques of the job plan, it produces a systematic approach, which is different and more productive than any product improvement or cost reduction approach. The two techniques of this phase are define function and evaluate function relationship. A paired comparison technique to determine the numerical value of the various functions is very simple and effective to use. The fourth one is creative phase, the creation phase. The objective of this phase is to create ideas for values, alternatives to accomplish the functions defined in the previous phase. The first step is to try answering the questions. What else will do? This phase requires creativity to the focal point. That means the first step is for brainstorming. And brainstorming is a very effective way of promoting creativity. In brainstorming, freewheeling is permitted. The two purposeful techniques to promote creativity are establish positive thinking and develop creative ideas. Next phase is evaluation phase. That means evaluation phase means to study what we have done. Will that work or not? The objective of this phase is to select for further analysis the most promising of the ideas generated during the creative phase and to subject the idea to a preliminary screening to identify those which satisfy the following criteria. So, will it work? Is it less costly than the present design? And it is feasible to implement. This phase of the job plan, together with its supporting techniques, must be undertaken with both care and diligence. For it is here that the judicial part of the mind is brought into active use. There are four techniques associated with this phase refine and combine ideas, establish cost on all ideas, develop functional alternatives, and evaluate by comparison. Fifth, next one is investigating phase. The three techniques of this phase further refine the selected ideas into workable and acceptable solutions, providing lower cost methods for performing the desired function. And the three techniques are use company and industrial standards, consult vendors and specialists, and use specialty products, processes, and procedures. Because this topic or this paper basically is related to engineering, so we will be using these terminologies in large. Next is recommendation phase. This is the final phase of the job plan in which the finally selected value alternative is recommended for acceptance and implementation. It is vital in the sense that the entire project of conducting value engineering would succeed only if the recommendation is accepted. The two techniques associated with this phase are present facts and motivate positive action. The presentation of facts can be either verbal or written, in standard format or in combined form. The combined strategy is the best. The final recommendation need not contain all the data, but it should contain sufficient information to enable decision makers to find the course of action to be taken. Now we will see the fast technique or fast diagram, which is what we said we will be using or is being used in value engineering too. Function, analysis, system, technique. Fast. The fast diagram, whose initial stands for function, analysis, system, technique, is a diagram constructed from left to right, which represents the logical relationship between different functions. And to the answer the question how and why. The four primary directions of the fast diagram are when, how, when, why. Now we will see how does this works. We have seen these four diagrams, four sides, top, bottom, right and left. At top we have when, and in bottom we have when, and on the either side we have how and why. How and why direction are always along the critical path, whether it be a major or minor critical path. The when direction indicates an independent or supporting functions up or activity down. Now, how the construction of a fast diagram of a ballpoint pen. Everybody has ballpoint pens with, with you. The first step is to identify all the functions of the parts. The parts of the ballpoint and functions of part are shown in the table. Now we will see how it is. Now see, how does this system works? We said how we will move. We will be moving from left to right. First of all, the weight, size weight. Normally a pen contains ink, a barrel. We have to see the how the ink will be kept, at what level it will be kept, how the control of the air so that the ink comes down can be maintained, that is control flow. How to hold the pen, that is position refill is there. Provide tension, enclose parts, restrict movement, hold parts. There are pen has a barrel, a refill, a cap. All these elements are there. Now the thing is that how does it works? What will be the design criteria? It will be the size and the weight. If we look at the pen works is used for writing only. Now it depends upon the quality of the ink, the comfort of holding the pen, and the color, the aesthetic part, which makes it valuable as well as costly. Now, if we talk about holding the pen, how the it will be gripped, we have seen pens with plastic body. We have seen pens with a plastic holder, but that is up to the vision and the application where it can be used, in which part it's being used, and how long it will you will carry a pen with you for a month, two. No doubt in that period you have to think of its maintenance also. Maintenance is that by putting up a new refill in it if you want to keep it. And now the thing is that why you are doing all this thing. All these functions are time functions. This is basically a form of relation. Now we will see what does the different function part of the pen does. Hip, it improves look, locate part, and chromium plating is the costly. Plastic neck, I told you. Hold part, provide grips, facilitate maintenance. Step in, tip. Spring, it provides tensions. A pen with that is what we use. Normally, there are different type of pens, but that is if the spring part is there, it is a pen which normally makes tick tick. Refill, containing control flow, restrict movement. Ink in refill, it makes mark. There are different marks on it. Plastic barrel, enclosed part, identify company, airflow. Hole in barrel, name on the barrel. This is the identification marks. Basic function, provide impression or make mark. And secondary function is to improve look, provide grip, control flow. To start with, make mark, that is basic function. The question is why do we need this function is asked. The answer is to communicate ideas. This function is shown on the left of the first diagram. And how do we make marks? The answer is by performing the functions, that is containing and control flow, which is represented on right side of the basic function. Next question is how do we control flow and contain ink? Then the answer is to position refill, that is by making use of the spring, which functions is to provide tension. Then the other function are to be considered. The question, when do we improve improve look all the time? And the answer is all the time you want to have or you think of improving it. The all time functions are placed on the right hand corner of the diagram. The diagram functions are represented as shown in order to determine the scope of the problem. The first diagram indicates scope rules, vertical broken lines. The left scope line is placed between the basic function under consideration. Make marks and highest order basic function communicate ideas. Design parameters are placed inside the scope line. In the next phase, the generation of alternative ways of performing desired function is taken up. What is the benefits of value engineering? Why do we opt for it? Value engineering helps in improving efficiency as well as effectiveness of products, systems, and procedures. In general, value engineering enables people to pinpoint areas that need attention and improvement. Secondly, it provides a method of generating ideas and alternatives for possible solution to the problem. Thirdly, it provides a means of evaluating alternatives, including intangible factors. Fourthly, it provides a vehicle for dialogue, documents the rationale behind decisions, and materially improves the value of goods and services. At the end, it must be re-emphasized that value engineering and value analysis is an extremely powerful methodology for cost reduction and value improvement and is becoming more and more popular. Its application to all areas are hardware, products, services, systems, or procedures, and on all function process, purchasing, designing, producing, packaging, physical handling, and distribution. Now we move to quality assurance. The basic definition of quality is fitness for use. And equally good definition is conformance to requirements. If anything comes to your expectation, you will simply say it is of good quality. That means it is fitting your use. Note that both in the definitions, quality is defined relative to use rather than as a good characteristic that may be intangible. That is the secondary part. But first part is whether whatever we have purchased is useful to us. That means it is fulfilling the concept or the things what you have thought about it. If a product or services lives up to your expectation, it is of high quality. Now, what is the cost of quality? It is a measure of the cost to the firm for a lack of quality. It is very difficult to measure an offer cannot be found in account books. One has to be careful, back calculate as most of the cost elements are hidden. Quality costs are distributed throughout the organization. Most organizations include only the cost of quality control department, whereas the cost of inspection and measurements carried out in production departments are often ignored. Most importantly, the cost of bad workmanship, wastage, and rework, etc., are often not included in quality cost. Quality is free, but it is not a gift. This statement sums up the opinion that effective, permanent quality improvement is difficult to achieve, but more than pays for itself is increased productivity. Quality management. Quality assessment is an investigation of the level of quality being achieved. Quality control, on the other hand, begins with assessment and includes action to eliminate unexpected quality. The typical quality control program is based on periodic inspection, followed by feedback of the results and changes or adjustments whenever necessary. Includes quality control, but it also refers to emphasis on quality in the design of products, process, and jobs, and in personal selection and training. Total quality control. You have heard of all these terms. TQC, that is total quality control. This refers to the marginal commitment to quality so as to include the quality aspect in every functional area of work, production, marketing, finance, and personnel. It also includes behavioral science based technique like quality circles and zero defect programs. Naturally, the management of quality is an extensive area of study. The concept of quality circles have been a runaway success in Japanese industries. A quality circle is a group of employees whose assignment is to identify problems, formulate solutions, and present their results to management with suggestions for implementation. Quality organization. Quality management ensures that an organization, product, or service is consistent. It has four major components, that is quality planning, quality assurance, quality control, and quality improvement. As far as quality management, it is focused not only on the product and services of the quality, but also on the means to achieve it. Quality is a judgment of how excellent something or someone is. What are the four types of quality control? There are several methods of quality control, and these includes X bar chart, Six Sigma, 100% inspection mode, and the Taguchi method. There are seven primary control quality control tools, which include checklist, fishbone diagram, control charts, stratification, Pareto chart, histogram, scatter diagram. All these parts you have already completed in your mathematics paper, that was MMPC 5. 5C stands for 5S stands for 5 steps of this methodology. That is sort, set in order, shine, standardize, and sustain. Then comes your acceptance sampling. What is the meaning of acceptance sampling or sampling inspection? One method of controlling the quality of a product is 100% inspection, which requires huge expenditure in terms of time, money, and labor. Moreover, due to the boardroom and fatigue involved in repetitive inspection process, there exists a possibility to overlook, and some defective products may pass the inspection point. Also, when the quality of a product is tested by destructive testing, that is, life of a candle or testing of electrical fuse, then 100% inspection shall destroy all the products. The alternative is statistical sampling inspection methods. Here, from the whole lot of the products, items to be inspected, some items are selected for inspection. In your maths paper, you were taught about sampling methods, sampling reason, sampling techniques. I'm talking about that part only. See, that was taught to you in mathematics, and we are now talking it talking about in MMPC 9, and that too in quality control. So that was what was taught to you there is being used here. If that sample of item conforms to the desired quality requirements, then the whole lot is accepted. If it does not, the whole lot is rejected. Thus, the sample item are considered to be the representative of the whole lot. This method of acceptance or rejection of a sample is called acceptance sampling. In general, acceptance sampling method proves to be an economical and is used under the assumption that quality characteristics of the item are under control and relatively homogeneous. Now, what is the classification of acceptance sampling? Depending upon the type of inspection, acceptance sampling may be classified into two ways. First one, acceptance sampling on the basis of attributes, and the second one is acceptance sampling on the basis of variables. In acceptance sampling by attributes, no actual measurement is done, and the inspection is done by way to go and not go gauges. If the product conforms to the given specification, it is accepted, otherwise rejected. The magnitude of error is not important in this case. If we take, for example, if we take cracks in the criteria of inspection, the products with cracks will be rejected, and without cracks accepted. The shape and size of the crack shall not be measured and considered. On the other hand, in acceptance sampling by variables, the actual measurements of dimension are taken or physical and chemical testing of the characteristics of the sample of material or product is done. If the results are as per the specification, the lot is accepted, otherwise rejected. Now, what are the terms used in acceptance sampling? First one is acceptable quality level. At what level? What is the level? How to determine that level? That above that it will be rejected, and if it is below, it will be selected or otherwise. If the desired quality level at which probability of acceptance is high, it represents maximum proportion of defectives which the consumers find acceptable, or it is the maximum percent defectives that for the purpose of sampling inspections can be considered satisfactory. Then comes your lot tolerance percent defective or rejectable quality level. Now, it is the quality level at which the probability of acceptance is low, and below this level, the lots are rejected. This prescribes the dividing line between good and bad lots. Lot at this quality level are considered to be poor. Average outgoing quality. Acceptance sampling plans provides the assurance that the average quality level or percent defectives actually going to consumers will not exceed certain limit. The concept of outgoing quality related with actual percent defective being produced. The AOQ level curve indicates that at an actual percent defectives in the production process increases. Initially, the effect is for the lots to be passed for acceptance, even though the number of defectives have gone up and the percent defective going to be consumers increases. Now we see over here what is happening. At the x-axis of the bottom horizontal line, we have percentage defectives being produced in the lot, and that is at the y-axis of the vertical, we have AQ, AOQ X percentage. At This level you can the average quality of the outgoing products, since the rejected lots, which are ultimately accepted, contains all non-defective items because of 100% inspection. Operating characteristics, that is the OC curve. This is the most important part. Operating characteristic curve for sampling is a graph between fraction defective in a lot and the probability of acceptance. In practice, the performance of acceptance sampling for distinguishing defectives and acceptable or good and bad lots mainly depends upon the sample size and the number of defectives permissible in the sample. The OC curve is the curve of an 100% inspection plan. Is said to be an ideal curve because it is generated by an acceptance plan which creates no risk either for producer or for the consumer. Usually, the producers and consumer risks are agreed upon and explicitly recorded in quantitative terms. Here you see it comes. This is the general form of an operating characteristics curve that passes through two stimulated points. First one starts from the quality region that is acceptable. Till at the top you see two parts, that is the maximum producer's risk, and the different terminologies are shown in the figure. What are the characteristics of OC curve? The larger the sample size of the acceptance number, steeper will be the slope of the curve. An OC curve of the sampling plan with acceptance number greater than 0 are superior to those with acceptance number as 0. And thirdly, fixed sample size tends towards constant quality and production. What are the advantages of acceptance sampling? The method is applicable in those industries where there is a mass production and the industries follows a set production procedures. The method is economical and easy to understand. It causes less fatigue boardroom and computation work involved is comparatively very small. What are the limitations? It does not give 100% assurance for the confirmation of specification. So there is always some likelihood, risk of drawing wrong inferences about the quality of the batch or of the lot. Success of the system is dependent on sampling randomness, quality characteristics to be tested, batch size, and the criteria of acceptance of lot. In the diagram, we saw producer and consumer risk. What does that mean? The acceptance or rejection of the whole batch or product in acceptance sampling depends upon the result of the sample inspected. There is always a chance that a sample may not be of true representative of the batches or lots from which it was drawn. This leads to the following two types of risk: producer risk and consumer risk. Producer risk is denoted by alpha. It is the small probability of a lot or batch being good or even better acceptable quality level, but yielding a bad sample and thus getting rejected. So, this probability of rejection of a good lot with otherwise would have been accepted is known as producer's risk. Try to understand this because the same theory was taught to you under hypothesis testing. in MMPC 5. Second part is consumer risk, that is beta. It is the probability of the batch lot being bad or worse than the limiting quality, but yielding a good sample and getting accepted. So that probability of a defective lot being accepted, which otherwise would have been rejected, is known as consumer risk, that is beta. Consumer risk is the risk of problems with a product that does not meet quality and go undetected and thus enter the market. This can lead to financial losses and other losses, including reputation loss of market, or even loss of lives. Whereas products producer risk, on the other hand, is the risk that a good quality product will be rejected or marked as bad product by the consumer or the buyer. That means quality is a game of risk. We take an example of aircraft engines manufactured by the firm, which is critically important. The safety of the aircraft as well as the passenger depends upon the engine. It is therefore necessary that the company produces products to the best specification and quality. If the engines have quality issues and the consumer, that is the jet manufacturer, accepts them, then the jet manufacturer faces consumer risk. The airline that buys those jets will also experience consumer risk. If the jet manufacturer rejects the engines, even if they are up to the specification, there would be no risk to the consumer. Instead, there would be producer risk. Remember, producer risk occurs when the engines are made to the specifications, but the consumer rejects them for some reason. The firm would not face any producer risk if the engines are accepted by the jet manufacturer. Now, process control, variability. All products and services have a certain amount of natural variability because of variations in the input as well as imperfection in the process. For example, different quality of raw materials could have been used and different quantities of chemicals could have been used in the process. This process variability may be measured by the process standard deviation sigma, which indicates how much the product will vary, even if the process is in control. Products have to meet specified tolerance imposed by their intended use. Accordingly, the natural variability must be substantially smaller than the specified tolerance. What are the causes of process variability? It is known fact that the variations happen. The root cause of the variation of a stable process includes material, environmental, equipment, and so on. There are a number of parameters of changes that occur during the process. Two types of process variation. Common cause variation is inherent to the system. This variation can be changed only by improving the equipment or changing the work procedure. The operator has little influence over it. The second one is assignable cause variation that comes from the source outside the system. What is the effects of process variability? However, it increases the average manufacturing throughput time and does nothing to reduce the variability is throughput time. The overall effect is to increase cost, to increase customer lead times, and to reduce delivery reliability. What is the common source of process variation? Potential source of variation includes gauges, standards, procedures, software, environmental components, and so on. Repeatedly in the variation due to the measurement device, it is the variation that is observed when the same operator measures the same part many times using the same gauge under the same condition. Why? What do you mean by variability? Variability, almost by definition, is the extent to which data points in a statistical distribution or data set diverge, vary from the average value, as well as the extent to which these data points differ from each other. But this is the straight line. The point is somewhere over, somewhere down, somewhere over, somewhere down, sometimes on the line. This is variability. Here we see that we will have three sigma limits. This is the process variability. This is what I told you just now. Normal level is 1.0025, and your maximum level to the standard specified level is till 1.0050. Now, there might be some basic assumption. We normally take 3 sigma to the maximum limit. Now you see 3 sigma plus and 3 sigma minus, and your normal level is 1.0025. That means you will be accepting 1.0025 plus 3 sigma or 1.0025 minus 3 sigma. That means from these two values, that will be the natural process variability acceptable limit. I think we cannot say that there is any loss of the quality or the process will be rejected or the object will be rejected. It can be shown that variation of more than 3 from the process average are very unlikely. In fact, it is about 0.25% if the process follows the normal distribution, and definitely less than 5% for most processes. The solid line represents the tolerance specified by the intended use of the product. Within the specified tolerances, a certain amount of process variability is to be accepted. However, it is the goal of the statistical process control to determine when the process variability is going to be out of hand so that corrective actions can be taken, preferably before the required tolerances are violated. This is generally achieved by control charts. Now, what is control chart? Samples are taken as soon as they are available, rather than waiting for the completion of a lot. This affords the opportunity to detect unplanned changes in the process shortly after they occur and take a quick action, such as adjusting the machine. A control chart is a visual display of the results of an inspection process, incorporating carefully derived limits to indicate unusual behavior. A control chart can be based on categorical information or actual measurement. Accordingly, they are called control chart for variables, controlling quality through measurement, and control charts for attributes, controlling quality through counting. Since control charts for variables are more commonly used and are more powerful. The control chart is based on the idea that the average of the sample of several items will tend to cancel out the normal process variability so that undesirable changes in the process will be more visible. Now, what are the different types of control charts? If we talk about continuous numerical data, so we will be using variable charts. And for that, we will be finding R chart and X bar chart. And if it is related to the category or discrete numerical data, we apply attributes chart, that is P chart or C chart. Variable control process charts plot continuous measurement process data such as length or pressure in a time ordered sequence. In contrast, attribute control charts plot count data, such as the number of defects or defective units. Control charts are constituted by upper control limit and lower control limit and the center line. You might have seen what is the diagram I showed you, 1.0025 plus 3 sigma minus 3 sigma. That was the at plus 3 sigma was the upper control limit, and lower control limit was minus 3 sigma, and the center line was the maximum limit. Now you see over here, this is a graphical relation what we are doing. We are This is a graph drawn between time and measurement. Now I will show you there are three lines, three different lines. If we see on the top, that is the dashed red line, that is upper control limit. Above that, everything will be, this is a process related, it will be out of control. And at the bottom, we have minus. Now, the thing is that 110 is the process average. You may see there are some values above it and some values are below it. And there is only a value which is outside the region. I'm talking about the green one which is marked. So that is out of the control point, and that is a specific case. Now we have to study at 3 unit time what happened and how it happened. That is the cause now. X bar and R chart. These are control charts for variables. This chart is used for quality characteristics which are specified as variables. That is, on the basis of actual measurement readings taken. The purpose or objective of this chart are to establish whether the process is in statistical control or not, to determine whether the process capability is compatible with the specification, to detect trends in the process so that it assists in planning, adjustments, and resetting of the process, and to show when the process is likely to be out of control. The number of samples of components coming out of the process are taken over as a period of time. Each sample must be taken at random, and the size of the sample is generally kept 5, but 10 to 15 units can be taken for sensitive control charts. For each sample, the average value of all the measurements and range are calculated. The grand average, that is x bar, is equal to the average value of the averages, and R bar is equal to the average of the ranges, and is found to be that we can calculate the control limits for X bar and R bar charts. Now you can see how it's calculated. We come to a conclusion. Normally in graphs we see a number. Now the question is how that number is accepted. How we get that number. Upper control limit, that is for X bar. It is X bar plus A to R. Lower control limit, X bar minus A to R. And for R chart, what you are going to do? Control limits for X bar and R charts. Control limit is here, it's plus and minus. And for R chart, it will be UCL R bar is equal to D4R. And for LCL R bar, it is D3 R bar. And these all values have the traditional conventional naming. Now the factor A2 D3, D4 are known as statistical factors. Depends on the number of units per sample. Larger the number, the closer the limit. The value of the factors A2, D3, and D4 are obtained from statistically quality control table. As far as long as X bar and R bar limits value for each samples are within the control limit, the process is said to be in statistical control. The various reasons for process being out of control may be faulty tools, sudden sufficient changes in properties of new materials in new consignment, breakdown of lubrication system, faults in timing of speed, mechanism, etc. Tracking of these causes is sometimes simple and straightforward, but when the process involved, now see, a new process of producing ball bearing is started. For monitoring the outside diameter of the ball bearing, the quality controller takes the sample of five balls bearing at 10 am, 12 am, 2 mm, 4 pm, and 6 pm, and measures the outside diameter in mm of each selected ball bearing. The result of the test over a 4-day production period are, let's see what happens. For Monday, at 5 times in a day, he took up the observation and he found different diameters. He is not aware, at now he is not aware, while he is drawing this table, he is not aware what is the exact applicable limit. Different diameters at different times, different observations are taken. R chart, X bar is found, that is the mean, and R is drawn. Now, what these numbers specify? For 4 days, 5 times, this exercise was performed. That means he has taken up the total values. The total of X bar is 1032.4 and R is 56. Now, calculate and draw the center line and control limit of the X bar chart. Draw the conclusion about the process, assuming assignable causes for any out of control point. From the table 1, we got A2 is equal to 0.577 for N is equal to 5. To calculate the center line control limit, we first calculate the value of X bar and R using equation. Here, X bar is your mean. Mean is summation of all the observations divided by total number of observations. I told you summation of all radius for the 20 observation is 1032.4. Number of observations are 20. That comes out to be 51.62. That is the mean diameter. R bar is equal to summation R upon N. That is 56 divided by 20. This comes out to be 2.80. Now, control line, control limit, X bar is 51.62. Now I'm finding out the upper control limit and lower control limit. Normally, this is the problem. How do we achieve this? Examples are shown, but now I'm telling you how that data is approached, drawn. Your UXL upper control limit X bar is equal to A2 R bar. You have every value with you. That comes out to be 53.236. Similarly, lower control limit will be calculated and that comes out to be 50.004. Now we construct the X chart by taking the sample size on the X axis and the average diameter of the ball bearing on the Y axis. Now, when this is drawn, This comes out to be. Okay. Sample number and average diameter of the ball bearing. This is the actual data is found. Now you can see that there are two values which are outside the region. One is at item number 4 and the other one is item number 12. Now, what is happening? This is an interpretation. The point corresponding to sample size 4 and 12 lies outside the control limit. Therefore, the process is out of control and some assignable costs are present in the process. To bring the process under statistical control, it is necessary to investigate the assignable costs and take corrective actions to eliminate them. Now, another step. When standard error and mean is given, center line is mean, lower control limit when the standard deviation is given, standard error is there. The normally standard error is sigma upon under root n. We have to take 3 plus and 3 minus. So see the change. Your lower limit is mu minus 3 sigma upon under root n, which has been represented as a sigma. And your upper control limit is mu plus a sigma. Standard error x bar is sigma upon under root n, where a is equal to 3 upon under root n, because your sigma is 3. A statistical controller. Okay, now another problem how to because as the question, you should be aware of what statistically it means. A statistical quality controller uses XChart for monitoring a quality characteristics of a product. If the process mean mu and standard deviation sigma are 105 respectively, find the central line and control limits for the X chart. It is given that A is 1.5 and N is 4. Now, mu is 100, sigma is 5, A is 1.5. You know that center line will be at mean, that is 100. Upper control limit will be, okay, A mu plus, this value comes out to be 92.5 and 107.5. Now, we have talked about X bar chart. Now we move to range chart. What is the difference here with that? The underlying logic and basic form of R charts are similar to that of X bar chart. The primary difference between X bar chart and R bar chart is that instead of plotting the sample mean and monitoring their variation, we plot sample range and monitor their variations in sample range. But here the thing is that your lower control limit will be this, and your upper control limit will be this. Now we'll see how does that work. Here it comes. This is for the range. The following point should be kept in mind while using X bar and R charts. In order to determine whether a process is under statistical control, we control both process mean and process variability. For that, we use X bar and R charts together. We first control the process variability, so we analyze the R chart before the X bar chart. If the R chart indicates that the process variability is out of the control, we first control the process variability by investigating the assignable costs and taking corrective actions to eliminate them. Only then we analyze the X chart because when the R chart is brought under statistical control. Many assignable causes of X chart are eliminated automatically. If the R chart indicates that the process variability is under statistical control, but X bar chart indicates that the process mean is out of control, we continue to use R chart but revise X bar chart. The center line and the control limits of X bar charts are revised by eliminating these points. As a result, the position of the control limit in the revised chart shifts, but the distance of control limit remains the same as in out of control case because we are do not change calculate R again. If both X bar and R charts indicate that process variability and process mean are under control, X bar and R can be considered as representative of the process, and the values are taken as the standard values. A statistical controller uses X bar and R charts together for monitoring the quality characteristics of a product. Sample size of 5 are taken from the manufacturing process at regular intervals. A normally distributed quality characteristics is measured and the X bar and R are calculated for the sample. After 20 samples have been analyzed, we have X bar equal to 6.40 and R bar is equal to 0.0877. Now compute the center line and control limit for X chart and R chart. So first of all, we will write in the mathematical notation form what is the information given to us. Here we are having n is equal to 5, k is equal to 20, x bar is equal to 6.40, and your r bar is 0.877. Note that the process mean and process variability are unknown in this case. So we will be using A2 is equal to 0.577, D3 equal to 0, D4 is equal to 2.114 for n is equal to 5. These values are all given in statistical quality control charts. Now, this is the mathematical part I'm showing. Center line control limit x bar chart A2 is equal to this is given. Now we have to first of all define CL x bar is equal to 6.40. Control limit, upper limit x bar plus A2 R bar. Calculated. LCL will be calculated. Now we see that your mean is 6.40 and your UCL is 6.451 and your LCL is 6.394. Center line limits for R chart. R bar is equal to 0.877. Now similarly we have to calculate UCL. This comes out to be 0.185 and for LCL it is 0. Now this table is the standard table which is available in the statistical quality control charts. Similarly, here also, okay, this I'm talking about this chart. These values are given to you. Your N is 5. You can see these values. This is what we have used. This is what I've written over here, and it is also mentioned over here. All these values for N is equal to 5. For N is equal to 5, it is given in the paper, in the problem. We will be using these values. Now, mathematically, X bar chart and R bar chart values have been made available to you. Now we move to inventory part, that is purchase system and process and inventory management. What is the role of purchasing function? Every organization, big or small, to varying extent, depends on material and services from other organizations. These materials and services are obtained through exchange of money. And this process of exchange is known as purchasing. Materials constitute an important ingredients of inputs to the activities of several types of organizations. Industrial industries require raw materials, components and equipments for their production. Service organizations require supplies. Spare parts are required for maintenance, operations, and so on. Everybody is dependent on somebody else. In most of the organizations, the value of materials are compared to other inputs to the system is high. In an industry, on an average, about 40 to 60% of the total money is spent on materials and related services. Similar estimates about the large sum of money involved can be made for public works department, electricity boards, development agencies and corporations, etc. Now, what is the objective? Purchasing principles are usually optimized by buying materials of right quality, in the right quantity, and at the right time, at the right price, from a right source, and also at right place. The main objectives are to make the users department of the organization from time to time aware of the range of quality of materials available in the market and to maintain the right quality of purchased materials based on standards, technical specifications, and suitability as determined by the user department. To produce at the lowest possible cost constituents with quality and service requirements. Thirdly, to ensure the minimum possible investment in service operations related to purchased materials such as transportation, inspection, storing and record keeping, etc. To maintain continuity on the supply, to ensure that scheduled activities are not interrupted, and to create goodwill for the organizations through healthy buyer supplier relationship. Then comes your purchasing function. In order to meet the above objectives of the purchasing functions, the requisite input and possible restraints and factors must be identified. The purchasing function is responsible for a host of decisions. Responsibilities of the purchasing department includes other related activities, that is vendor rating and development, make or buy, value analysis, surplus disposal, control and audit, maintenance, and development of procedures, forms, records, and reports. Everything is included. Now you see purchasing decision function. What are the inputs? What are the restraints? And what is the output? And none other than what is the demand factors. If we talk about inputs, it is purchase requisition, product specification. Restraints are legalities, management policies, available resources, market condition. If we talk about demand factors, items used continuously, large single orders, small value purchases, and normal purchases. The output will be supply sources, timing, price, quality, and quantity. Purchase requisition or purchase intent. When we have to purchase anything, so we have to generate it intents. A purchase requisition is the primary and authorization document describing the needs item. Most organizations have a standard requisition form for the use of its all department. The format, however, may change from organization to organization. The three most common types of requisition forms are standard purchase requisition, traveling purchase requisition, and bill of materials. To start with, the standard purchase requisition form. In this form, this is a standard form for a given organization. Different organizations may use different formats. A standard purchase requisition form is used for non-recurring requirements of items and normally contains the following information: requisition number, date of requisition, name of the department of the section who needs it, accounts to be charged, description and quality of items, and what is the purpose of the item. Now, second one is traveling purchase requisition. This type of form is used by stores for recurring requirements for material and standard parts. The requisition form is the format of a card for a single item containing the information about the item, which is the name and brief description, coded name, quantity, order, reorder point. The information is provided from the potential suppliers, record of recipients and issues, and so forth. This card we used for many requisitions. And then comes your bill of materials. This is the list of all items for a finished product and is prepared at the time of engineering drawing of the product. The bill of materials and the production schedule are sent to the purchasing department, which computes the total requirement of each part for each period of production. This eliminates the necessity of typing numerous requisitions for usually a large number of items. Then comes your restraints and factors. Restraints limit the alternatives available to purchasing department for its decision. Similarly, the type of purchasing procedure adopted will depend on the factors related to the demand for that. Purchase decisions are restrained by legal considerations, management policies, resources availability, and market conditions, and many more reasons. Legal consideration: the purchasing department commits a good deal of finance when a purchase order is placed. It is therefore necessary to have sufficient understanding about the legal aspects of the purchase. The Indian Sales of Goods Act 1930 and the Indian Contract Act of 1872 come over some of the important legal aspects. The important relevant law are law of agency, law of contract, law pertaining to sales of goods, including patent laws, warranties, trademarks, etc. And number fourth is arbitration. Professional legal advice related to these laws is must for major contracts involving large sum of monies or extending over a large period of time like imports. Management policies, centralized versus decentralized purchases. Management may choose between centralized and decentralized organizations or a mixture of these two types of purchases. Centralized purchasing has economic advantage due to specializations and input standardizations, and thus it is attractive strategy for multi-plant and multi-location activities using related items. Resource limitation. Finance is the major resource which can seriously influence the purchasing activity. The corporate finance is shared by all the departments of the organization, and purchase department must operate within the allocated budgets. This may lead to sometimes to the purchasing decision somewhat less optional than what it would have been had the purchase department been able to make to get the finance as and when desired. Sometimes we have heard that the finance department says that the money which was taken has been exhausted and we are waiting for next installment to come. That is the condition. And the third one is market condition. The market conditions relate to short term market situations, which are influenced by supply and demand, as well as overall national economy. Thus, during shortage, the reliability of supply may be considerable, most important than the price. The purchasing strategy should therefore change to cope up with these situations and ability to anticipate these conditions measures to a good extent. Professionalism acquired by the purchase personnel. Now, what are the demand factors? Based on the demand patterns, the items can be grouped into four basic categories. Items used continuously. Items that are continuously used with a very predictable demand can be handled under blanket purchase order. A contract is negotiated with the supplier for a fixed period of time, maybe 6 months or a year, with quantities, delivery dates, discounts, etc. The price may be fixed or capped open, in which the case the market price at the time of delivery will be applicable. Blanket order conserves the time and efforts of the purchasing department since they have a blanket approval of it. That means to that limit, the purchase manager is capable of doing the purchasing. Large single orders. The situation of large single orders usually occur in case of special machinery or other special goods such as computers, vehicles and buildings, etc. Therefore, considerable planning and evaluation are involved. Third one is small value purchase. The low cost, infrequently used items are purchased usually by the concerned departments using petty cash or by identifying some small local suppliers. The fourth one is normal purchases. Items other than mentioned above fall in this category and are handled by the normal procedures, that is, following the complete cycle of purchase process discussed above. Now, purchasing decision. For purchase requisition, the purchasing department generates purchase orders, which is a legal document. Purchase orders forms vary in their format and their routing through the organization. A purchase order should contain at least the following: purchase order number, date of issue, name and address of supplier receiving the order, quantity and description of items, required delivery date, shipping instructions, price and payment terms, and other conditions governing the order. Some of the decision functions leading to preparation of the purchase orders are supplier selection. How will you supply? How you can say that the material will be purchased from the supplier? Information on external source of supply can be obtained from numerous references. Industrial advertisement of supplier appearing in newspaper and periodicals, supplier catalogs, supplier salesman, trade union, trade directories prepared by government agencies and trade associations, lists of suppliers approved by the government agencies, inquiries through advertisement or individual communications, and records of the organization's past purchases. Timing of purchase. The organization is primarily interested in an adequate supply of material at the best price consistent with quality requirements. Timing is not a critical concern when the purchases are made in price stable market, but becomes critical if the market price is unstable. Now the thing is that price determination. Price per unit of an item companies comprises the unit purchase price, transportation cost, handling cost, inspection, insurance, and the administrative variable costs. The right price simply means the lowest possible total price for the organization. The typical approach for price distributions are published price lists, competitive bidding, and negotiation. Price lists published by the suppliers give initial indications of the price. Normal practice requires at least three competitive quotations wherever possible. Generally, competitive bidding is most applicable to standardized products that are widely used and are produced to stock. Bids are normally secured when the size of the order exceeds some minimum amount. Negotiation is the approach resorted when time is too short, the number of bidders are too small, and the value of purchase is high. Willingness to compete is lacking, or the specifications are too vague. In such circumstances, the buyer contacts the potential suppliers and negotiates for their fair price and prompt delivery. And advanced planning and analysis are expected to bring satisfactory results out of the negotiation. While determining the price, shipping terms should also be clarified. The shipping terms establish who will pay the freight charges, when does the buyer take the legal title to the goods, and who will prosecute loss and damage claims against carriers. Then comes your discount. Costing, we are talking about the cost of the company. So every parameter has to be studied and has to be considered. Then comes the discount. An important aspect of price determination involves discounts that can be secured. Following types of discounts are common, that is trade discount. This to protect certain distribution channels when it is economical to buy from the distributors rather than from the manufacturers. Quantity discount for purchasing worth beyond certain amount of money. Seasonal discount for purchasing in off season. Cash discount for prompt and full payment. But these are the factors which are considered. Now comes purchasing organizations. Purchasing department is usually under the general manager at par and with other functional departments such as engineering, finance, accounts, manufacturing, and marketing, etc. A good structure encourages the assignment of specific responsibilities, specific authorities, and smooth chain of command of delegation. It should lead to the development of policies that permit routine decisions to be made by the subordinates. Within purchase department, the structure may be worked out by the following approaches. Number one, organization by function. It is based on the principle that job should be organized so as to promote maximum possible specific specialization of skills. The total purchasing job is broken on the basis of specialization, such as processing for purchase requisition, floating inquiries, selection of suppliers, preparation of purchase orders, receipt inspection and storing, licensing with account section, and record maintenance, etc. See how much labor has to be done. Then comes organization by products. The item purchase are classified into groups, and each group is assigned a personnel who specializes in purchase of that particular type of material. Then comes organization by location. This is applicable for the organizations which are large and have several plants. Each plant may have a purchasing department. Then comes organization by stage of manufacturing. In case of manufacturing, sometimes it is advisable to organize the purchase activities according to the stage of manufacturing. That is, raw material, parts, and sub-assemblies. What are the procedures, forms, records, and reports? Procedure. Different organizations have different procedures. By procedure, we mean the entire set of steps in which a purchase transaction is carried through from its inception to its conclusion. These steps together form the purchase policy of an organization. Since there are wide variations among industries, companies, organizations, products, and personnel, it would not be feasible to establish a single set of procedures which would apply to all cases. Now, this is a systematic purchase procedure involving some of the steps. We have to make the purchase, so we have store departments, suppliers, accounts. These are the departments which are responsible. Now you see, if we talk in terms of purchase and store department, that is related to purchase order and its copy. And from store to the purchase, it is inspection and receipt report. From purchase to accounts, it is the purchase order copy. And the inspection and the receipt report that has to be sent to the accounts department. And from purchase to supplier, we have to take quotations, and then the quantity will be discussed. And in the second phase, when the purchase order will be sent to the supplier, and the follow up will be done by the purchase department. Now, see how these departments are interrelated among themselves. Purchase forms. Forms are very important tools for purchasing department to standardize and communicate with internal departments of the organization and external agencies such as supplier and local government bodies. The number of forms required depends on the size of the organization, the purchasing system employed in the organization, and the accounting and internal control methods in the effect. Purchase forms for the following functions are usually employed: purchase requisition, request for quotation, purchase orders, follow up, and receiving and inspection. Now comes purchase orders, purchase records. Since purchasing is a repetitive process, accurate records are a necessity for efficient operations. These records provide a history of what has been done in the past: supplier, price, discounts, and quantity of delivery, etc., and provide a wealth of information upon which to base function future decisions. Maintaining a good record system will increase operating cost, but expectedly it should bring some handsome savings in the long term. Then purchase reports. Since the purchasing department handles a sizable proportion of corporate finance, it is desirable to have some summary reports periodically, quarterly, annually available to the management. And some of the important reports are: total value of purchase, allocation of purchase value against major items, allocation of purchase value against each requisition department, and budget for the purpose for the next year. But this will help in budget market, vendor evaluation and rating. It is not always too easy to identify the good supplier. Records maintained or produced from some other sources about the vendors help in their evaluation and rating. Usually, a combination of price, quality, quantity, delivery time, and service, etc., giving relevant weightages to these factors, is used to rate the vendor. In addition, a checklist can also facilitate rating from department standpoints. Some of the points are: reliability. Is the supplier reputable, stable, and financially strong? Are the supplier's integrity and ability above doubt? Is the supplier going along with product improvement? And is the supplier competitive strength is to price and quality, etc., proved by the past experience? About the technical capabilities, can the supplier provide assistance as to application engineering? Can the supplier provide assistance as to application development? Can the supplier provides assistance as an analytical engineering analytical engineering to improve process? Next one is convenience. Can the supplier help reducing acquisition cost through personal visits, telephone calls, incoming inspections, rejection of defects and spoilage, etc.? Can he offer other related products? Is he qualified to help in solving difficult problems? And does the supplier package his product conveniently? Then comes the availability. Does the supplier assure delivery in time? Are his stocks locally available or at short notice? Is the supplier's location advantageous? That means costing. Can he plan his supply to minimize inventory? Or can he be dependent on for a steady flow of material? These are the criteria which are to be understood. And then it's not over now. After sales service, does the supplier have a service organization? Is an emergency service available? Are parts available when needed? Then comes sales assistance. Can the supplier help building mutual market? Will he recommend our product? Does the use of supplier product enhance appearance of our product? How many criteria? Yet 2025 criteria have been discussed right now. Vendor, and that is to the vendor evaluation. Recognition that there is a need for having good vendor. It is essential that suppliers are obtained from vendors after an evaluation of his capabilities. The buyer who has to do the evaluation is evaluating the performance before the vendor has delivered anything. And number two, product quality submitted by vendors has always been evaluated and used as factor in making purchasing decisions. Recently, the evaluation have been formalized by the use of vendor rating formulas, which provide a quantitative measure of vendor quality. These ratings are primarily used for choosing, comparing, and selecting vendors. Vendor rating is not a tool for making decisions or submitted lots. Computerized purchasing system. The attractive characteristics of computers such as high speed, huge storage, quick retrieval accuracy, versatility, and diligence on one hand, and increasing complexities in purchasing on the other make an excellent match of for computerization of purchasing system. The declining cost of computer system is an additive factor, although there is are no complex arithmetic computation involved in purchasing. The requirements of quick processing of requisition, follow up, and payment, etc., find a computer of immense help. One can see the computer has the following files: inventory file for each item, list of the suppliers, budget allocations for each department, master purchase file condensing the previous purchases. In addition, the computer has facilities to print and the quotation request, purchase orders, follow up, and inspection reports, etc. When a requisition is received, the relevant data are entered through the appropriate program. Nowadays, the screen and the template designs are proving much more convenient and foolproof. The computer checks the inventory status of the item, and if in stock, the items are issued and inventory record is updated. If not in stock, the program finds the classification of the item, that is, whether it is continuously used item or a special item. From the supplier list, it finds the suppliers who will supply the item and prints quotation request. The program also checks the budget of the department and account head to which the sum is to be debited. Now you can see that what I was talking to you, what I was teaching to you in MMPC 8, here it is being applied. That was programming. How the programming has to be done. Now see the application of that programming structure. On a single click of the requisition, how many things are interrelated as such? The software should be that much effective. The programming also checks the budget of the department and accounts head to which the sum is to be debited. The data from quotations are entered and the computer displays the comparative statement. It will select the supplier and print the purchase order. Upon receipt, it will update the inventory of the item. Now see, after receiving. In addition, computers are very useful for monitoring the status of the purchase order to assist in follow-up actions. In addition, it is very useful in processing exceptional reports such as budget is over, orders not supplied in time, and payments not made in time, etc. It may be mentioned that most of the computers, especially small and mini computers, offer a host of utilities which are very useful for computerization of the task like purchase. Computerization of purchase, such as receiving, issuing, instruction, stores, inventories, and handling, etc., can easily bring the desired coordination among other functions of materials management as well as among other departments of the organization, such as production, design, engineering, finance and accounting, marketing, etc., through suitable design of database and information system. With this, I will be stopping over here and I would like to know, do you have any questions regarding what we discussed right now? You might have seen that how information system and the finance department or the purchase department works together. That is the application of information system. Any question from anyone?
So far, so good.
You've understood the concept of value engineering, value analysis, purchasing. Tomorrow, I hope we will be starting with inventory and your
Sir,
waste
are you,
management. You can write it.
are you able to just summarize how information systems is used in finance, just on high level? I think I got lost.
Just now, I told you that a requisition has been made for purchasing. That information will flash everywhere. It will first That requisition of purchase has been made by the department which is using it or who is needing it. As soon as that information is punched, it will straight away go to the store because I want that. I'll simply say that I want this pen. What I will do, I will write a request that I need a pen, and I will provide every specification. The pen should be of this make and all that. That requisition will go to the store. A store will reply it that we don't have. Now this process, if you don't have, if the store doesn't have, it will go to the purchase department. Purchase department will write a request for money. It will go to the finance. Finance will see to it. I'm just taking an example of it. Finance will see what is the reason why it is not available. If it is not, it should be procured. What is the importance of it? And when you are sending this request, so your purpose of it is also has to be shared. Then finance department will ask or will issue a notification to the purchase department to purchase it under this category and this purpose and this much of quantity can be purchased. Now purchase order will be generated. It will go, things will be procured, things will come to the organization and it will be inspected, and in the store department that will be updated. As soon as the in store department it is updated, it will be informed to it. Simultaneously everybody will get the information that the pan is now being available and it can be taken up by the from the store by the concerned department who has sent the requisite of it.
Thank you very much. I think I can relate with your
Yeah.
example on and how we do it at the office. Yeah. Mm.
Yeah.
We
The
raise
other thing
purchase
is that
orders and requests.
everybody, I don't know whether you are working or not, but normally I take up that example which can be understood by everyone, and then it can be applied
Yes,
in the organization where you people are working. Any
indeed.
other
Thank
question?
you.
Thank you, ma'am. Any other question from anyone? Should we conclude today's session over here?
I think let's conclude today's session. It's been a long 2 sessions today.
And tomorrow again we have two sessions.
Not a
But it is
problem.
easier
We'll be
for
here.
it is easier for me what I will be telling you in information system with computers. I will be applying here in the next 2 hours in the actual
Mm-hmm.
process
Mm-hmm.
application of IS. Is the question the same question was asked by you? How IS will be applicable in finance? So I took up an example of PAN and I
Mm-hmm.
told you how the information system shares information in everywhere in an organization.
It's a fine example, sir. Thank you. Remember it.
Thank you. Okay, so I'm concluding today's session and we will be meeting tomorrow.
Indeed. Have a pleasant evening, sir. See you tomorrow.
Thanks. Bye bye.
Bye.
Okay, sir. Goodbye.